let's talk cryptography, and in particular how you're going to learn to crack the code. First, though, I've got a secret message for you. Here it is, 99, 3, 48, 10, 2, 1, etc. You see the rest of the message on the screen. We're going to learn how to unencrypt or decrypt that message back into its plain text version. Here's how. So first, the code creator began with a plain text message. They took a normal message in everyday English and wrote it down. That's the plain text message on the left side of your screen. And then they had something called an encryption key. This is separate from the message, and now this encryption key was applied to the unencrypted plain text, and out of that came an encrypted message known as ciphertext. We started with plain text. We did some operation on it to get ciphertext. That ciphertext is passed on to the message receiver, and separately they should have received the key. You see that second key on your screen? They took the encryption key, turned it into a decryption key through an operation that I'll show, and then they applied that decryption key to the ciphertext, and together they got an unencoded or decrypted plain text message. The operations that happen when we apply the key to the various texts are going to be some matrix math. There are actually 3 skills you're going to need in order to learn how to decrypt this particular message that I've shown you. The first skill is I want you to understand that we can encode letters as numbers. And here's one such conversion table. There's actually many, many ways you can encode letters into numbers. We've chosen this one. The second skill you're going to need is about multiplying matrices. Now here's the first real new thing that we've had in this lesson. How in the heck do we multiply 2 matrices? Well, there's a couple of rules in how to do it, and I'm going to show you one here by hand, and then separately I'll show you how to do this on the calculator. For this project, you will be multiplying matrices on a calculator. Okay, so here's the example that I want us to do, the matrix A times matrix B. First of all, you have to check that it's eligible to multiply these 2 matrices. You'll notice here that matrix A is 2 rows, 3 columns, and matrix B is 3 rows, 4 columns. The inner terms, the number of columns in A and the number of rows in B, must match. We can multiply. Here is the algorithm for multiplying A times B. Row 1 in matrix A and multiply each element by the corresponding element in column 1 in matrix B, and you sum up those products. So this is 1 times 5 plus 2 times -1 plus -3 times 7. 5, -2, -21, -18. I move now to the second element in the AB product matrix by doing the first row of A times the second column of B. And the process continues. Having exhausted all of my multiplication options, I'm done. So this is a 2-row, 4-column matrix. That's the product of matrix A and matrix B. Now you can do this multiplication process on your calculator as well. To do so, go to the matrix menu and go over to Edit and edit both matrices that you want to multiply. Here I am entering matrix A. Next, I'll return to the matrix menu and choose matrix B, set the size correctly, and enter all those elements. Finally, I'll return to the matrix menu and choose the names of the two matrices I want to multiply. You'll notice here that I don't need a multiplication symbol because that's implied on these calculators, and press enter. Part 2b of this problem, multiplying matrices, is a special case of multiplication. When you just happen to multiply a matrix by its inverse, you get out the identity matrix. And here's a picture of what the identity matrix looks like. Part 3 of 3 is that you need to know how to find the inverse of a matrix. We're not going to worry you with how to do this by hand. This is exclusively a calculator operation. It's worth noting, however, not all matrices have inverses. You have to at least start with a square matrix. First, re-enter the matrix menu and edit a matrix of your choice. I'll be working with matrix C. One thing to know is that you can only find the inverse of matrices that are square. I've set up a 3 by 3 square matrix, and I've already entered all my elements. I'm going to now exit the matrix editor and go pick my matrix from the names menu. Mine is matrix C, and I want to find it to the -1 power, or the inverse of the matrix. Finally, if desired, I can also translate all those ugly decimal values into some beautiful fractions. There you have it. Put it all together now. A matrix times its inverse is the identity matrix. An encryption key matrix times a plain text message matrix is equal to a ciphertext matrix. So therefore, using the identity property, the inverse of the encryption key times the encryption key times the plain text message is equal to the inverse of the encryption key times the ciphertext. Simplifying, that means the plain text message matrix is equal to the inverse of the encryption key times the ciphertext message. You have now 3 new skills. You can encode letters as numbers, you can multiply matrices, and you can find the inverse of matrices. The last 2 are calculator-only skills. Now you're ready to encrypt and decrypt messages. Here's a visual of how to think about what's happening. Encryption is a process of multiplying an encryption key matrix by a plain text matrix in order to receive a ciphertext matrix. The decryption process takes a decryption key matrix, multiplies it by a ciphertext matrix in order to receive a plain text matrix. Congratulations, your skills and conceptual knowledge are ready to go. Good luck cracking the code.